Wanted to see the title slide. That's what it was. So before I get started, just a little bit about me. My name is Lucas Friesek. I've been working on graphics drivers since about 2016, starting on OpenGL Safety Critical. So I worked in that space before that you heard about for Vulkan Safety Critical, and I also worked on Vulkan Safety Critical. Since 2 years ago, I moved over to working at Igalia, where I have been working on the Mesa open source driver stack. In the last year, I was contributing to Lavapipe, which is what I'm going to be talking about today in this presentation. The work I do in Lavapipe is mainly around platform integration and improving WSI performance. But I also touch other areas too, such as issues with shader compilation. So why am I talking about Lavapipe? Well, if you don't know what it is, it should hopefully be interesting. But this is a little bit of a continuation from a discussion that happened at Vulkanize last year. Last year during the panel, there was a big comment of, there should be a reference driver for Vulkan that everyone can use everywhere and have an idea of what's supported and how to do things. Lavapipe is not a reference driver, but it is a conformant Vulkan driver you can run on basically everything, including pretty much every OS that anyone's using for development. So hopefully it is of use to you. So what is it? It is a software rasterizer for Vulkan. It's currently conformant to 1.3. Since early or late last year, it exposes all of the extensions promoted to core for Vulkan 1.4, but it hasn't been run against conform for Vulkan 1.4 yet. But if you have a Vulkan 1.4 application, there's a good chance you can run it against Lavapipe as well. So it's open source. It's part of Mesa, which is a big open source driver project within the Linux graphics stack, but that doesn't mean it's limited to Linux. It runs in a lot of places, and it uses LLVM to compile the shaders into native code, so you can actually get decent performance and run useful things. A brief history about it. It was started in 2020 by Dave Arlisle. He's a pretty prolific contributor in the open source graphics space. You might have heard of it at the time as Valium, which is a strange name. It sounds almost like some kind of medication or something. It was quickly renamed to Lavapipe, which better fits in with the other software rasterizer in Mesa called LLVM pipe for OpenGL. And originally it was not conformant. It could run a few samples, but chances are it would probably crash on anything that you wanted to run against it. In 2022, it reached 1.2 conformance, and very shortly after 1.3 conformance. And as I mentioned before, in 2024, it now exposes all the extensions required for Vulkan 1.4. And you can run a lot of stuff. You heard in the Blender talk that George uses it in Blender for testing. So real applications run against this. It's something that is more than just like a toy. But CPUs are slow for doing graphics. Like, why do I need a software renderer? There's a few places where it can be interesting for you to use. One example is like when you don't have a GPU, like maybe you're doing device bring up, maybe you're running in a cloud VM that doesn't have a GPU and you want to run some Vulkan code. Well, it's an option for you. Virtual machines are a very common place where you don't have access to a GPU, so it can be very useful. And the last area I think it's pretty useful is, you want to test your code. You have a workstation set up with a GPU in it. You don't want to go turn off your computer, plug in another GPU, and you just want to see how your application responds to a different driver implementation. Well, you can just run on Lavapipe and compare. So on the other side that Lavapipe is useful is that it implements a lot of Vulkan extensions. So if you want to try some of the newer stuff that the working group is putting out there, there's a good chance that it's implemented in Lavapipe. And for example, when the working group was working on device-generated commands, Lavapipe was extensively used for conformance testing of it, as it was one of the first Vulkan implementations to have device-generated command support. And hand in hand, it was being developed with CTS in the extension development. So again, in the use case, you know, running on virtual machines. When I talk to people and they ask about software renders, this is like the big use case. Someone has like a Cloud VM or a CI runner or something like that, and they want to run Vulkan code. Like you can do this if your CI runner like runs Linux. Probably you don't even have to install anything. It's like available already. So it's a very big use case. For like a fallback, if you have an application that doesn't really have like super high graphics requirements, especially for like CAD tooling and things like that. If you need features and the device you're targeting doesn't have those features, you can use Lavapipe as a fallback so that end users can continue to run your application. And now moving over to the current state of Lavapipe from use cases. As I mentioned before, 1.4, all the extensions in it that were promoted to core are supported. There's also a lot of interesting extensions that you might want to play around with that maybe your device doesn't support yet that you can try out there, such as ray query, ray tracing pipelines, device-generated commands, shader objects, mesh shaders. This isn't an exhaustive list. There's a website you can check out. I forgot to add the link to it here called Mesa Matrix. You can just Google that and find it. And it shows what extensions are supported by Lavapipe as well as all the other Vulkan and OpenGL drivers that are part of Mesa. Now, Lavapipe is not the only other or Vulkan software render available. You might have heard of Swift Shader. That is another software rasterizer for Vulkan that you can use. Though you might not want to. This is my pitch to tell you that you probably want to use Lavapipe instead. Swift Shader only supports Vulkan 1.3. It doesn't have all the extensions in it for 1.4. As far as I know on the development side of it, they are only really adding stuff that like Android needs to run. So I don't think there's really much contribution going there besides what Android needs in it. And testing on my own system, I got like a 42% improved performance on some basic benchmarks running on Lavapipe over Swift Shader. If you're on Linux, also Swift Shader does not support Wayland, as far as I know, and will crash. And so if you're using Wayland, you probably want to use Lavapipe as well. Now, moving over, okay, this is what it is, the current state. You can run like a lot of stuff on it. How can I use it? Like you want to use Lavapipe, like how can you get your hands on it? Well, today it runs on all the major operating systems, Windows, Mac, Linux, Android. If you want to use it, there's kind of 3 options available to you to get it. Depending on your platform, you might have official binaries for it. You might have unofficial binaries for it, or you might have to build it from source code. So I'm just going to cover the different platforms and what options you have to do and how you can look into doing those options. So on top of that, if you're not as familiar with the driver implementation side of Vulkan, one of the nice improvements from Vulkan over OpenGL is we have this beautiful thing called the Vulkan loader, and it's a very nice portable way to load different drivers following a fairly common interface using ICD files. So when you get Lavapipe, assuming it's not an official package, you'll need a way to load it. There's this cool environment variable called VK driver files that you can just point at the file to find it. If you have an official installation of Lavapipe, you probably don't need to do this. But if you're working on a different platform, you might need to. There's documentation inside the Vulkan loader that is very helpful that explains this. I don't think this is something the Vulkan configurator currently exposes, but I think it might be nice at some point in the future if more people are using Lavapipe to have that more easily available. Now, for platforms, for Windows, unfortunately, there are not official binaries for it, but there is an unofficial Mesa package for Windows that provides Lavapipe, as well as a number of other things inside Mesa, such as Zinc and Dozen, which are layered driver implementations for OpenGL on top of Vulkan and Vulkan implemented on top of DirectX. You can also build for source on Windows. There's documentation inside of the Mesa project that'll tell you how to do that. There's not too many dependencies besides just having LLVM and C compiler or C compiler. On Linux, if you're running Linux, probably you already have Lavapipe available on your computer and you do not have to do anything. Most distributions ship it as part of their default Mesa package with their drivers. But if you did want to build it from source, there is documentation inside of Mesa that shows you how to do that. If you want to run on Mac, this is something that was recently supported, actually after Vulkanized last year. A fellow from Autodesk who was at the conference went and added Mac support. First using X11 on Mac and then a native WSI implementation for Mac. So it currently works. There are no official packages, so if you want to use it, you'll need to build it from source. And I think this also made it the first conformant Vulkan implementation on Mac OS. The last platform I'm going to talk about is Android. So in the theme of lies, Lavapipe did work on Android before, but with like a big caveat on it. You needed to run a like DRM compatible kernel mode driver, which you don't always have if you're running on Android. So some of the work I was doing last year enabled Lavapipe to run just with the normal Android graphic memory allocator. But it's a lot more complicated. You know, Android isn't as much of an open platform. So if you want to run it, I wrote a lot of documentation for how to run Lavapipe on Android, and then also just Mesa drivers in general on Android. So if you're interested in Android, please check out those links. If you find an issue in the documentation, please file an issue so I can improve it. Now, the last thing I'm gonna talk about is a call for people to contribute. Lavapipe is a community effort. It's not owned by any company. It's open for anyone to help out, whether that's filing issues when you test your application and stuff doesn't work on it, whether that's you want to learn a little bit more how stuff works on the driver side and you want to try writing code and implementing features, or if you just want to talk to developers. We're all interested in that in the open source community. So there's a link here if you want to file issues. It's a little old school. There's a IRC channel that a lot of developers hang out on called DRI Devil on the OFTC IRC channel that you can go on and get in touch with developers. And there's also a mailing list that you can send an email to, and there's a good chance people will see it. Lastly, I'm going to just show some examples. Got a few scenes here. These are all running in real time on my laptop, my development laptop. You have the VK sample. You have some of the VK cube, VK sample, and most importantly, which does run in real time using software rendering as it should, VK Quake. And that's it. Thank you very much for your time.
Thank you very much for the talk. That was really, really cool. Does Lavapipe support compute, and do you have any kind of parallelization of those shaders? I was just wondering, with my OpenMP stuff for CPU, would I have any mileage kind of just going to Vulkan compute shaders?
Yeah, so I don't know how well it compares to OpenMP, but there is parallelization. So through the LLVM layer, it uses, when it's generating the IR, it will use intrinsics to try to take advantage of stuff like AVX to get better performance. And then also it is multi-threaded, so you can have it use more of your the cores on your machine. When you start running more you can configure how many CPU cores you want it to use, but a lot of the time, at least on the rendering side, you start running into memory bandwidth issues before you run out of CPU cores. I don't know about the compute side, if that is as much of an issue.
Cool. Thank you very much.
So for my case, let's say I wanted to target Intel, AMD, NVIDIA all off one piece of hardware. Can I configure Lavapipe to represent the different capabilities on these different hardwares and then deploy to each of them?
Could you repeat the first part of that question? I'm not sure I quite understood it.
like for example, video capabilities are different between Intel, AMD, and NVIDIA, right? Now, if I wanted to write some implementation of video that I wanted to target AMD, Intel, and NVIDIA, can I deploy to 3 different instances of Lavapipe to test my implementation?
So Lavapipe is running on, like, it's a full Vulkan implementation running on the CPU, right? So it to your application, it just appears like another Vulkan driver. So I'm not sure I totally understand your question.
So
and
how
it
do you
relates to
change the hardware capabilities of the implementation of Vulkan?
So it advertises what it can support based on like what's implemented in Lavapipe, and the algorithm it uses for like rendering. So things like the device capabilities, texture size, whatever, that's all part of the Lavapipe implementation. You can play around with them a little bit, I guess, if you wanted to make it look like a real device that you have and match those capabilities. Is that kind of where you're going with it?
Yeah, so I could test my implementation against different hardware types without changing machines.
Okay, yeah. So you can play around. I don't know if there's a nice API for doing that, but it's not that complicated to build Lavapipe. So you can just go tweak the tables and make it look like another device.
Awesome, thank you.
I wanted to quickly respond to your thing. That's actually something the Vulkan profiles toolset, the layer, can do, where it can fake pro capabilities, and it will sub out it only works if the hardware actually supports the things that it can support, and it just kind of masks off things that it doesn't support. So that's what I would check out in terms of easily being able to redo things. But if you just rebuild from source, it's another way to modify it. I wanted to quickly add there's another environment variable. Instead of VK driver files, it's VK add driver files. And that's for when you want to use Lavapipe and the other drivers on the system. Because the VK driver files replaces whatever drivers on the system there would have been with the one you provide. So that's useful if you're trying to use it, Lavapipe, as the fallback layer or fallback driver.
Okay.
Any other questions? In which case, let's thank our speaker.